finish up 9.3, we're just going to look at some semi-quadratic equations. But now our exponents are rational, not whole number powers. But notice they still fit how I describe semi-quadratics in that the powers are double each other. Okay? My middle power is 1/3. Double that, it's 2/3. Right? My middle power is 1/4. Right? If I double 1/4, that's 2/4, which reduces to 1/2. So it still fits the category. These are quadratic-like, so they operate in the same way. It means we can factor them in the same way and solve the same way. So again, I need to factor. I need two x values that are going to multiply together to get x to the 2/3. And we're going to use our middle power, x to the 1/3 and x to the 1/3. Because when I multiply these two, I get to add the powers. I get us 2/3. And factor normally. Factors of 8 that combine to get 2. 4 and 2. Looks like +4 and -2 would work out to get the +2 in there. And we solve. Set each factor equal to 0. So x to the 1/3 equals 2 after we add 2 to both sides. And again, at the end, we're going to use our techniques from mod 8. And if I want to get rid of this power, I can just raise it to the reciprocal power. If I raise it to the 3rd, right, 3 times 1/3 is going to cancel out. But I also have to raise the other side to the 3rd. So we have x equals 2 to the 3rd. 2 is 8. And over here, x to the 1/3 equals -4. Raised to the 3rd power. -4 times -4 is 16. Times -4 again is -64. There's our two solutions to this quadratic-like equation. So hopefully this is looking a lot familiar. There's not much variety in these. We're going to factor. I know it has to be 3, so that's going to be 3 and 1. And again, I need two powers of x that are going to multiply together to get x to the 1/2. Okay, we're always going to use this middle term, x to the 1/4. Again, because 1/4 plus 1/4 is 2/4, which reduces to 1/2. So that works out. Then I need to factor normally. Factors of 3, that'll help me get to 8. I think the 3 back here is going to be important. 3 times 3 is 9. And 9 and 1 can combine to get 8. So that would be +3 for 9, -1. From there, two quadratics to solve. Or two factors to set equal to 0 and solve. So x to the 1/4 equals -3. And again, we can raise this to the power of 4, which is going to help cancel out the exponent. -3 to the 4th. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Add 1. Then divide by 3. And then raise both sides to the 4th. that's going to be 1 over, in this case, 3 to the 4th is again 81. So I think we'll have our two answers there. So both quadratic in nature, factored them, set each factor equal to 0, and we solved using a little bit of mod 8 to solve for x by using properties of exponents. Okay, I've got one more example to do. We'll just do one that doesn't have rational exponents. This time we'll put one in that has negative exponents. But again, notice my powers are double each other. Negative 1 doubled is negative 2. So it fits quadratic. But I do notice this equation isn't in standard form. It's not equal to 0. So I'm going to set this equal to 0 by subtracting. Oops. Subtracting my x term, subtracting my 6. X to the negative second, minus x to the negative first, minus 6, and now on the right side have nothing. So we put it in quadratic form. Okay. I'm going to factor it normally. Okay. Again, using this middle power, x to the negative first, x to the negative first, because when I multiply these two together, add the powers, I get negative 2. Factors of 6 that combine to get 1. That should be 3 and 2. Minus 3 plus 2. So that's going to get us x to the negative 1 plus 2 equals 0. And x to the negative 1 minus 3 equals 0. So x to the negative 1 equals negative 2. Right? And when you're dealing with negative exponents, and you're trying to solve an equation with negative exponents, right, I tend to think the friendlier way to do it is to rewrite the expression with a negative exponent, as we always do. We don't like our answer to have negative exponents in it. So if I'm going to solve this equation, it's pretty hard to do with the negative exponent. So I rewrite it as 1 over x equals negative 2. Okay, and now you can think of this as kind of a cross multiplication problem. Right, from mod 7, we can multiply across, and we end up with 1 equals negative 2x. Divide by negative 2. And we get negative 1/2. Right, same thing over here, x to the negative 1 equals positive 3. And I really don't like working with that negative exponent, so I'm going to write it as 1 over x. I'm going to think of them both as fractions, so I can cross multiply and get 1 equals 3x. Divide by 3. Right, and get a solution of 1/3. Again, final emphasis here is nothing changed in terms of solving it like a quadratic. Put it in standard form, factored like a quadratic. The only thing that's changing is we're using our mod 8 skills and what we know about this is mod 5 actually, what we know about negative exponents, what we know about rational exponents to help solve the equation from there. But outside of that, that's kind of the end of mod 9. 9.4 has some word problems in it, but you're going to be using the same tactics as we do at 9.3, 2, and 1. So, all right, good luck with those. I think that's it.